Hello everybody and welcome to another Mystery Box Function Challenge. In the purple box there is some mystery math and your challenge is to figure out what that is. Because it's a Friday, today's math is supposed to be even more challenging than usual. You can try this out by using the link in the description, and when you think you've got an idea, come on back and see if we get the same thing. All right, let's begin. I'm going to put in a 0. Okay, 0 gives us 0. How about a 1? Okay, so that looks like a non-repeating decimal, so maybe a square root function, maybe a trig. How about a 2? It's leaning towards trig. Let's try a 3.14. An approximation for pi. Aha, and now we're back down to 0. Let's just throw in a 1.5 for an approximation of pi over 2. And then let's just put in, I don't know, a -5. Whoops, I meant a 5. Right, and then a 6.3 to approximate 2 pi. All right, so at least on the right half of the graph, we've got what to me looks like the cosine function. So the sine function. So at 0, we put in an angle of 0, and then we take the x and the y of that coordinate where it touches the circle, and the y is the sine. So it looks like we have, at 0, we've got 0 for the y coordinate, and then it goes up to 1 at pi over 2, and that's our 1.5 approximation right there where it reaches the top. And then at pi, 3.14 was our approximation. We're back down to 0. And then at 2 pi, all the way back around to 0 too after going down again. So this looks exactly like the sine function. This looks like it's just sine of x, at least on the right-hand side here. I think maybe something funky is going on the left, though. I noticed that when I put in that -5 by mistake. So let's put in a -1. So -1. -1.5. And okay, let's try that again. -1.5. I don't know what it thought that was. There we go. And then let's do -3.14. Yeah. So what you would expect here is, if this is the sine, if it's just sine of x, this waveform would continue on and it should go down. Oops, let's do a different color here. It should go down here and then back up and then up here, etc. Not that high, but it should have that same form. And what we're getting, actually, it looks like we're getting the reflection of it across the y-axis. So we've got this, and then zip, it looks like a mirror right there across the y-axis. So what could be causing that? I think sine is part of our answer, but not the whole thing. Now, recently we actually saw a graph of the absolute value of the cosine of x, and that did something interesting. Normally the cosine would start at 1 and it would go down to 0 and so forth like that. But what we saw is, instead of doing that, it did this, boink, boink, all the way along, boink, boink, like that. So the absolute value caused it to take the parts that were below the x-axis and reflect them above. So to get the reflection left and right, we're going to do something just slightly different. We're going to take our x, not the whole function, not the sine of x, but the x itself, and put that in the absolute value brackets. What that's going to do is, any negative value that you put in, it changes it to the positive. And the result of that is going to be this reflection across the y-axis. So how can we think about that? So if we put in, pi over 2, we get 1. If we put in -pi over 2 in here, it turns it to a pi over 2, and we get 1 again. And that's how you're getting that sort of reflection across the y-axis. So I think this has got to be our answer. Let's go ahead and take a look. Yeah, so the sine of the absolute value of x, and we can graph that. Huh, kind of a funny looking graph, isn't it? So this point at 0 where it sort of stops the normal continuous pattern of the waveform and reflects it on either side. And you may think of that just like you think of the absolute value function, which looks like that v that at 0 has that sharp turn. Same thing, but with the sine function reflected on either side. Well, how did that go for you? Did you suspect absolute value was involved here some way? Let me know. Thanks, everybody.